Carbon dioxide levels in the ocean are increasing due to large carbon emissions from burning fossil fuels. And the carbon emissions go into the ocean and lower the pH, which causes the water to become more acidic and is called ocean acidification.
According to the National Oceanic and Atmospheric Administration, global shipping accounts for 3.1% of total CO2 emissions globally. The latest study done by CE Delft projects shipping emissions to increase by up to 120% by 2050. This dramatic increase in emissions will have devastating impacts on our oceans if we continue to ignore it. According to Yale Environment 360, since the Industrial Revolution, CO2 in the air has boosted ocean acidity by 30%. When CO2 is absorbed by seawater, a series of chemical reactions occur, resulting in the increased concentration of hydrogen ions. This has devastating impacts on marine ecosystems and animals who need the pH levels not to change in order to survive.
The model on the left shows how shipping products increase the amount of carbon that is going into the ocean. You can see on the right-hand side of the model that the pH has decreased compared to the left side. This is due to the carbon dioxide that is being used for the boat. The coral and other organisms are less healthy and smaller due to the fewer carbonate ions, and the ocean has more carbonic acid, hydrogen ions, and bicarbonate. The model on the right is the Earth's energy budget, and it is a balance between the amount of energy that gets to the Earth from the sun, the amount of energy that flows from Earth back out to space. When a larger amount of carbon is going into the atmosphere, it causes the energy budget to go out of balance by absorbing thermal heat radiated by the surface.
Our CO2 calculation is CO2 plus HO3, which equals H2CO3, otherwise known as carbonic acid.
Our experiment represents the effect of carbonic acid on seashells, which emulates the effect of ocean acidification. For our experiment, we got 4 seashells, weighed them, and put them in separate cups. After, we filled 1 cup with 100% carbonated water, 1 cup with 75% carbonated water, and 25% distilled water, 1 cup with 50% carbonated water, and 50% distilled water, and 1 cup with 100% distilled water. We put the shells in the cups and a glass lid on top and had the shells stay in water for 5 days. The seashells that had more carbonated water than distilled water ended up losing weight, and the ones with less carbonated water ended up either staying around the same weight or increasing in weight because they were able to absorb more water. The reason the shells lost weight was because the carbonated water has a lower pH, causing the shells to decay.
Our pH calculation is CO2 plus H2O, which equals H plus HCO3 negative. In our CO2 calculation, it also shows how the consumption of carbonate ions impedes calcification. There are still ways for humans to reverse the effects of ocean acidification in our lifetime. One study from the World Resources Institute found that seagrass meadows should give corals an 18% boost in growth. They also have the potential to increase aragonite saturation by up to 2.9 units and the pH by 0.38%. This idea is far more achievable than bigger schemes of geoengineering. The low cost and easy accessibility to local communities makes seagrass meadows a very realistic solution to ocean acidification. According to the National Library of Medicine, in some countries the share of protein from fish can be greater than 50%, including in West Africa, Asian coastal countries, and many small island states. A lack of action will result in the devastation of marine food chains, which may not directly affect us, but will greatly affect the people who rely on our oceans for survival and who have little or no say in how we should treat our oceans.